Hello, my name is Nathan Rini. I'll be presenting the REST API today. This is for the Slurm user group meeting for 2020. And here's our schedule today. There'll be 4 separate presentations. 2 of them are already complete. And then there'll be Tim after mine. And just remember that there's always about a 5-second delay for questions, but questions are welcome and the channel is moderated. And I will probably be answering the questions afterwards because of the delay. All right, as I said before, I'm Nate Rini. I'll be covering the REST API. Today we will be covering the Slurm REST API, starting with what is a REST API in general, followed by the OpenAPI standard. We will then discuss the Slurm REST API implementation. After that, we will cover security and authentication. A quick overview of the changes for Slurm 2011 release to be provided. We will then go through a list of example queries. We will end up with a quick summary of scale-out, which can be used to experiment with Slurm. REST as an architectural style was being established in 2000 and has been slowly gaining popularity through the years for using existing technology and overall simplicity of use. It allows clients to query a server in a standard way that is very easy to implement by anything that can do web browsing, which is basically everything at this point. REST API is an HTTP-based protocol for communicating with a server. Communications are done over a clear text in a format that is readable by humans and machines. Clients make requests and the server responds appropriately. A quick comment on the REST standards. REST is an informal standard composed of several standards combined into a single service with all the benefits that come along with such a dichotomy. We do our best to be as compliant as possible with relevant standards to make sure all types of clients can connect without issue. Please open a bug report if a compliant client is having issues so we can make sure Slurm REST conforms. REST API is a mechanism for making the requests, but it does not fully document what is expected from clients or servers. OpenAPI is one standard for the documentation of what is expected and what will be provided. While there are other documentation standards, we chose OpenAPI due to its availability of client tools and higher level of adoption. The important part of OpenAPI is that there is a specification provided by every REST server of what is expected of clients and what the server will do with those requests. The specification can generally be fed into a client generation tool to make it easier for end users to use. Tools already exist to create human-friendly documentation from the specifications as shown here. Here are some third-party clients for OpenAPI. The Slurm REST API is a tool framework for developing easy ways to convert REST requests into Slurm's internal API. The REST API's responses are not limited to the Slurm RPC's internal format and can provide output to users in a more friendly manner, just like the command line tools do. Next, I will cover the possible production architectures for sites to deploy. Starting with an existing cluster, JSON Web Token authentication can be added to as an alternative authentication mechanism. Then Slurm REST can be run outside of the munch perimeter to allow clients with JSON Web Tokens to send requests. Here's an example like the previous where JSON Web Token authentication is used in addition to an authentication proxy. The authenticating proxy can be used by sites for caching and site-specific authentication. The final example is how Slurm REST can be set up with an existing cluster for single users to allow their applications to query Slurm REST directly. Slurm REST has several different modes of operations depending on the use case. A site may use one or potentially all of them for their workflow. The daemon mode will have Slurm REST listen on a given set of ports and communicate with clients via sockets. This mode is expected for dedicated servers for clusters and may be scaled up with load balancing for very large clusters. The iNet mode is made for smaller clusters to allow clients to query as needed without the expense of running a daemon at all times. The INET mode also allows scripts to pipe directly into Slurm REST for operations on an as-needed basis. Slurm REST is open source and is expected that anyone could run it at any time. The user executing the Slurm REST daemon determines how the daemon will be able to handle requests. With an unprivileged user, Slurm REST will have no extra permissions and will execute everything as that given user. Using the local authentication mode is suggested for this operation. The Slurm user or root user operation is designed for cluster-wide services that will be trusted to act for any given user on the cluster and must be set up with care. In general, this should only be done with an authentication proxy to ensure site security policies are enforced, which is explained later. Slurm REST was designed to be as simple as possible by acting as a plugin-based framework for serving content. Plugins are provided to add content that is registered at load time and then bound against specific OpenAPI compliant URLs for callbacks for content generation. Slurm REST itself provides a generic framework for handling HTTP methods and data abstraction layer to ensure that content plugins only need to be concerned with their operation and not the implementation of the protocol standards. JSON and YAML are currently built in and can be translated between natively. Per the OpenAPI standard, the OpenAPI specification can be generated and provided to any client that requests it. Here's an example of using INET mode locally for scripting a request to Slurm REST. This example is equivalent of calling sdiag and returns the information in JSON format. Here's an example of using listen mode for from remote clients. In this case, Slurm REST will listen on 3 sockets for the clients. Here's an example of retrieving YAML formatted response instead of the default JSON. Slurm REST can natively accept YAML or JSON for input and output. I will now change the topic to security with respect to Slurm REST. Slurm REST is designed to default to as secure as installation as possible. We have been taking feedback from sites and adjusting the default security setup as we go to lockdown edge cases. Feedback is always welcome. There are currently 2 built-in plugins for doing authentication. First is local authentication, which relies on the Linux kernel to provide information about the client user. It will then authenticate as requesting user when running as root to allow the user to make requests as if they had called Slurm REST directly. If called by an unprivileged user using local authentication, then only processes owned by that user will be allowed to make requests. The second is JSON Web Token authentication base, which is an independent standard for authentication. Users will be asked to provide their username and token for every connection. Slurm REST will then translate the request into a Slurm internal RPC format to allow the controller to verify the token directly. We are fully aware that every site has their own security rules and compliance that must be implemented. Instead of trying to implement each of these security systems into Slurm REST, we give sites 2 options: write a C plugin or use an authentication proxy. In general, adding an authentication proxy should be straightforward, as they've been used in the web world for years. Both Apache and Nginx already have authentication proxy functionality. The idea is that it will be substantially easier for a site to set up their own specific authentication system with Apache or Nginx than write a new C-based plugin for Slurm REST. Sites can also choose to add connection encryption by using an authentication proxy. We start with an example of using JSON Web Tokens only and not an authentication proxy. We connect to the login node and become a test user named Fred. Fred then requests a JSON Web Token from the Slurm controller using the scontrol token command. We export the token directly into our shell environment for simplicity. Next, we'll use 2 headers to pass our username and token using curl to talk to Slurm REST. While this process is relatively simple, the user must be able to communicate with the controller using munge to retrieve a JSON Web Token initially. The other option is to set up an authentication proxy that will authenticate and authorize a user activity, which imposes fewer limitations on sites. Here's an example setup of an authenticating proxy that could be used with Slurm REST. The user will log into the proxy and receive session cookies. Every user request will include a session cookie, and the proxy will then pass the request to Slurm REST for processing. This will allow a site to control access independently of Slurm REST API, potentially with an already existing system for authentication. Next, an example where we use a very simple authenticating proxy. We start the cluster and connect it to the login node. We then become the test user Fred. First, we log into the authentication proxy, which in this case is just telling it which user we are. We use the cookie jar functionality in curl to save the session cookie. We then proceed to make a request using the session cookie and get the expected result. I will now switch over to the planned changes to the Slurm REST API in 2011 release. First major change of Slurm REST API was converting to be a plugin-based system for authentication. Previously, the authentication was built in, and Slurm REST API attempted to determine the most suitable authentication based on the Slurm configuration and the clients. We decided to make this explicit for sites to choose what they wanted instead. As an added bonus, sites can now add their own authentication plugin, which can be stacked with existing plugins as wanted. I will provide a quick example of the built-in plugins now provided with Slurm. I provide it right here. Continuing the changes are the new content plugins. In Slurm 22, there was one single source of content for Slurm REST API, but we needed a new way to add more content that didn't break backwards compatibility. Since Slurm REST API follows the OpenAPI standard, all of the requests have unique paths which allow us to use plugins that register their path at startup. This gives sites the ability to choose which plugins are loaded depending on the site's needs. This also allows sites to add their own custom content plugins that will be served along with existing plugins if desired. Now with the new content plugins, we have an easy way to apply versioning to all the content. Each plugin will be based on specific version and the type of the request fulfilled. This will allow sites to choose which content plugins are loaded at runtime. It also gives them the ability to remove older versions as wanted. In general, once the specification is released, the only changes made will be break fixes. We will instead opt for a new version path and a new specification for any changes. All the content from 2002 release is now contained in the v0.035 plugin, and we have no plans to change that plugin, just as we have no plans to change the v0.036 after the release is tagged. Next, we are still adding more content to Slurm REST API. Thanks to a sponsor site, we are adding some accounting capabilities to Slurm REST API. This will add the ability to view jobs, QoS, accounting, associations, TRES, WC keys, and users in accounting. It will also be possible to change accounts, associations, and users. I will be skipping details as this is still a work in progress and nothing is final yet. A notable change is the new v0.036 content plugin for 2011. It is based on suggestions from Andrew Bruno to make Slurm REST API generated OpenAPI clients easier to work with. As always, we are looking for feedback on how to improve the specifications to ensure easy client creation. Good news, everyone. We have examples to share. We start with job submissions of each type and then continue controlling jobs and viewing them. First, we have an example job submission. In this case, the job details are provided in a packed JSON string. That job request is then posted to Slurm REST API using curl command with a JSON web token for authentication. At the bottom, we see that the job was submitted without errors and the job ID number is 3. Second, instead of curl, we communicate directly with Slurm REST API using the HTTP request. In this case, demo is the request we are about to send. Here we use the INET mode of Slurm REST API to read the contents of demo directly in. Slurm REST API will then respond with that job that has been submitted. We then verify the job using SQ. We will again use direct communications to Slurm REST API to submit a heterogeneous job. Same as before, the job is submitted and the job ID is provided. We now verify the job ID is using SQ. This time we'll submit an array job. Same as before, we get a job ID for the submitted job, and we verify the job ID again. In this example, we use the delete method to cancel a running job. Job is identified in the URL path. We submit the request directly to Slurm REST and then verify the job is canceled using scontrol. Next, we have an example of dumping all the job information. Note that Slurm REST will basically provide all the information about the job that the controller will share. Finally, we make an equivalent request to calling sdiag. During this presentation, we mentioned and used scale-out for examples. Scale-out is a Docker Compose-based cluster where Slurm can be safely tested. It uses the isolation of Docker to start a fake little cluster on your machine and should be runnable at almost anywhere with enough memory. It already comes with Slurm REST fully configured and includes an example authentication proxy as a demonstration. Scale out some basic commands built in to make it using simple. Please look at the README for details. All right, now we'll go to questions. All right, first question is, will these examples be published alongside the slides? Yes, all the examples will be published with the slides, and it will be on the SCEDMD website ad infinitum. All right, looks like there are no more questions, so I'll be continuing on. Oh, wait, there we go. Can we use SSL is another question. And the answer is yes, you can use an authentication proxy to wrap the Slurm REST with SSL or with any encryption you want. Not SSL because it's already depreciated. I'd suggest at least TLS 1.2. And using the proxy mode, you can also add extra authentication if you wish. Next question is, how long will older versions of the content plugins be distributed? That's an open question right now, and so far we don't plan on depreciating any of them currently, but in future releases we'll have to make that decision. For now, they won't be, and they'll be included in 2011. Next question is, are there other alternative authentication except JWT? And as of right now, no. That may change in the future, but for 2011, it's just JWT. Next question is, does the REST API reduce the stress on the controller side compared to normal commands like sqsinfo? The default setup does not. We suggest putting a proxy that will cache the request. That should reduce the stress substantially and allow the sites to control how long the caches are kept and give the site full control. And since these are all existing functionalities on the website, we don't really document them directly, but there are tons of guides online for you guys to use. Next question is IPv6 supported? And the answer is yes. Slurm REST supports IPv6 natively, and it already works. Let's see if there are any more questions. Next question is, how can I reach the Swagger URL? OpenAPI standard specifies that a request to /OpenAPI/v3 will dump the OpenAPI specification. And that's standard for any REST server compliant with OpenAPI. Next question is, do jobs submitted via REST API run through the job submit filters like Lua, job submit plug, filter, fenable? Yes. The job submit filter is on the server side, and it will always be implemented or always applied if configured. Let's see if there's any more questions. looks like we're out of questions, and I'm going to continue on. Oh, wait. Looks like a new question came in. Give it a second to go through. The question is, does the Slurm REST D work as a buffer for the Slurm control D? Answer is no. The idea is that you'd use either Apache or Nginx to work as the cache. Slurm REST D is just a translator. The next question is, what about Spank plugin CLI options? Currently, Slurm REST D does not implement any of the Spank plugins interfaces at all. At least on the client side. It might be on the server. I have to look that up. Alright. Looks like we're out of questions now. So I'm going to go on to the next slide. Yep. Okay. The next presentation is by Tim Wickborg with Slurm 2011 Beyond. It starts at 11 a.m. Mountain Time. Ends on a separate YouTube live stream. Please see the SCEDMD Slurm YouTube channel for links. Thank you.